Alright, so I wanted to show a couple updates to Galactic Smith. This is a game that I've been working on with a good friend of mine on Discord. I will show his name here. His name is Ayub, if I'm pronouncing that correctly. Um, now I met Ayub on Pixel Pete's server, and he is a wonderful pixel artist. And I've been working with him for quite a bit now, and I very, very much have been enjoying his art. Now, in this update, I wanted to kind of cover two topics I've done. So, I turned the music into its own library file that we link at compile time, and then I'm also using the Ming GW instead of Visual Studio 2022 like I used to. Mainly because I've been going back and forth between Linux and Windows. And so what happens is, since I'm turning all this art into code, we have we've run out of heap space on compile time. So, for example, if we take a look at this furnace entity, I'll just open a notepad here. You can see this is a very, very long file, and yeah, there's a lot of blank spaces, and we can talk about how I should probably be compressing that data, so on and so forth. However, for the animations that he provides off of his files, instead of like trying to redact certain information, a lot of that stuff lines up very, very nicely if I just leave it alone and create a spreadsheet from it. So kind of give you an idea of the workflow here. If we go into assets, and I'm going to go into this folder that I call commission. He's been doing this off the kindness of his own heart and working with me on this. But give you an example. So let's say, let's go over here to this one. Let's say that this is the player's animation moving right. We then take that and I make a CPP file. And this is kind of what we're left with. Now generally, I'll take that and erase it, and we just kind of have like a header file that does that pre-compilation. And eventually the idea is to take all of that artwork and turn it into its own library. Another feature I've been working on within Galactic Smith here is Perlin noise. The reason being is I can technically, if we take a look at the code, I can load in data and read it from Tiled. So Tiled is an amazing program where you can build map levels. And you can export CSV files, and that, in this case, that's what I was doing. And then depending on what tile data, we can load it in, read it. But to be very honest, if I'm making a game where you can explore space, this, that, the other, I don't have the resources or the time to sit there and make every instance level. And especially when it comes to caves and other situations, that's not a good idea. So instead, I looked into some Perlin noise algorithms to determine some seed stuff. We can argue that this should be random. However, but without further ado, I want to kind of explore what we have going on so far. So yeah, let's let me jump in here into the build folder and run this. So first off, that music, and I want to notice as well, there's no folders for art. We have some DLLs. We have the DLL that I've made for the music. This CMake file stuff just helps build this using the Ming GW64 system. We generate our own CMake, so on and so forth. So in here, we can see what we got. So I've, for now, have loaded in this robot just to kind of show how we can have different layers, and I guess like the best way to see it is you can see the shadow. However, let's check this out. So let's hammer out this rock. Let's hammer out this rock as well. Notice how the UI covers, and if we look, we have, we got our rocks inside the UI and whatnot. If I right click when I have two rocks, it'll actually generate this, and this is the best way to see this layer system. Currently, we do have collisions on that guy. We don't on this. This is just a test, but you can also see some of the layer systems going on here as well. Because what you want is the player. You want the player to appear in front of the object and on top of the shadow. But you also want him to be occluded by that part, right? So been working on a layer system, a draw system, and just to kind of show that really quick, I use a implementation called interfaces. People with Java might be extremely familiar with this. In C++, it's slightly different, but not really. You make a virtual function. I call this struct drawable, and inside a layer struct, I say, hey, we have instead of a string and a value, we have an enumerator, which is just numbers. So we have numbers that I've determined to have these phrases with them. And for that layer and that list of drawables, we call it a render layer. And this is how we draw to the screen. So if we take a look at the actual game file here, so let me go to game, and we scroll down to where we're drawing. In the main scene, we just call render scene, off scene, and all that's doing here is says, hey, draw. This is drawing everything by layers, and that way we can just say, hey, add to a layer. This system adds to a layer, and for things that are instantiated, as in like things that are created upon runtime and not on compilation time, we can do something like this where we just add to the layer a shadow and occlusion. In this case, this is the top of the tower, this is the shadow of the tower, and the actual base of the tower based off of the compilation. So if we go back to, I believe that would be inside scene, you can tell that all furnaces are on the entity layer to start with. So the base sprite is entity layer, then there's shadow layer, then there's the occlusion layer. This allows some cool stuff. Now, the other part is check out the Perlin noise. We have some basic grass, right? Nothing fancy. Then we got like this water. You got some land in here. And this seems fine. And yeah, the animations are probably too slow. At the moment, we can speed that up. That's everything is very nice and decoupled for work-wise. We do have some lava going on and another ground area, more grass. And so this was generated pseudo-randomly and using the Perlin noise system. And yeah, so one other thing to note, we have some little screen shake when we hammer, and we have all directions of hammering. And I suppose, just to check something, let's hammer some coal, hammer some of that iron ore as well. I'm gonna come up to our furnace here. I'm gonna grab some coal, I'm gonna grab some iron. We're just going to kind of wait in this menu. Now there should be some type of loading bar, and yeah, boom, you can see we have this. Now this is a placeholder, as you can tell. That is a rock, but for the means of practice and implementation and having like sprites in the place of others while we work on the game, this is suited and fine. The next set of things to work on would be the functionality of this workbench and the robot. So kind of how I see the way the game would go is you, the player, will manually collect these resources until you can basically, in a sense, build a robot, right? Like you'll build this furnace, you'll build this, you'll be like going back and forth. Think like Factorial. And then instead of conveyor belts, we use robots. And then the robot starts doing it. And eventually you will be able to make cooler things. And a little sneak peek preview here, we're talking cars. Not only are we talking vehicles, we're also talking spaceships, space travel, and this is why the Perlin noise is extremely valuable within this project. But yeah, thanks for taking a look.